All right, so day 3, last part of the notes for today, for this packet I've been giving you. It's factoring difference of squares. I'm going to tell you now, and I don't know why this is. This is my favorite type of factoring because it should be the fastest, easiest factoring you've ever done. And every year, I have students who look at these problems. They'll be great today. You'll come in tomorrow and be like, I don't know how to do this. And I don't know why. Please, somebody tell me. If you can tell me why you get it today and then tomorrow you're like, I don't know how to do that. Please tell me, because I can't figure it out. Jonas? It could be. But please tell me. If there's something, these are the easiest factoring. I don't know why people like freak out on these. Yeah.
I don't think about it, so when I come back, I'll be real confused.
But that's after the summer. Like that I get. But from today to tomorrow? I don't know. Try to absorb this, would you guys? These are my favorite. And you will hear me. I'm like, these are my favorite factoring because they're fast. They're easy. Okay. So if I give you that, and I would ask you to factor it. Is that, I know some of you know how to factor this already, but is that in the form that we talked about yesterday? How many terms? There was 3 terms yesterday, right? It was always an x squared, an x, and a number. So which part is missing? The x. So could I, in theory, rewrite this? Could I write this as 16x squared plus 0x minus 25? Could I do that? Hold on, let me attack this from a couple different directions, okay? Does that mean the same thing? I can add 0 to anything, right? It doesn't change anything. So now is it in the form that we're used to? It is. Okay, so let's just factor it like you've been factoring everything. Is there a GCF? No, nothing goes into it all. Last one's negative, so my signs are opposite. 1 plus, 1 minus. Options for A, 1 and 16, 2 and 8, 4 and 4. Options for C. All right, so I'm attacking this just like I've done every problem up to this point. Okay? 1 and 16, 2 and 8, 4 and 4. 4 and 4. So 4x and 4x. 1 and 25 or 5 and 5? 5 and 5. So if I check this, I get 20x minus 20x, which is 0x, which is what I had. Okay, let's talk about what we got going on up here then. So I factored it just like I did everything. I'm just trying to get a 0 in the middle. What do you notice about the numbers of the problem I started with? They're what? I can take the square root of them, right? They're perfect squares. You guys recognize perfect squares? Right? 1 squared is 1, 2 squared is 4, 3 squared is 9. Those are all your perfect square numbers. So yeah, 16 is a perfect square. 25 is a perfect square. Okay. In order for me to get this to happen where that middle term cancels out, what kind of signs must I have? They got to be opposite, right? If they're both plus, they're not going to cancel. If they're both minus, they're not going to cancel out, right? These canceled out. I got nothing left, which is what I want. So if I want a factor where these are 1 plus, 1 minus, what has to be true of this sign? It has to be negative. Mm-hmm. You can. Mm-hmm. Now, hold on. There we go. This goes back to the flow chart that I gave you. Is it yellow? I think yellow. Every year it's on a different color. I can't keep track. All right. So obviously GCF is still first. Notice this flow chart flips into 2 categories here, right? We just did things with 3 terms, and that's how we did it. Could I take that 2-term thing? Did I change it to 3 terms so I could do it like that? Yeah, I did. But if you're like me, I'm lazy. I don't want to write a 0x in the middle. That's obnoxious. It takes an extra step. 2 terms, these are called difference of squares. What does difference mean? Not the same. It means subtraction. Difference means subtraction. So, okay, difference of squares has to have a minus sign. A square, those are your perfect square numbers. Then this does not work. We'll talk about that in a minute. Hold that thought. So since it has to have a minus sign, the last one has to be negative. They're always plus minus. And I'm just taking the square root of the numbers. That's what goes in there. Okay, every time. All right, again, last one has to be negative, so my signs are going to be opposites. All right, so let's kind of look first, not even factoring, but which ones are a difference of squares. Because as of today, the only thing we can factor with two terms, GCF you can try to pull out of everything. But to factor it further, you have to have a difference of squares. So is x squared minus 25 a difference of squares? Yeah, you have two terms. You have a minus sign, and is 25 a perfect square? Yeah. Okay, so let's try to factor this then. Last one's negative, so it has to be plus minus. What's the square root of x squared? X and x. Square root of 25? X plus 5, x minus 5. Are we seeing why these are my favorite? Do I even have to really check them? No, they should be easy, fast, like you don't even have to think. Okay, how about this one? Is this a difference of squares? 12 is a perfect square? Is there a GCF in that one? Okay, let's take out the GCF first. So even though it's not a perfect square per se, can you still take out GCFs? Yes. All right, so what's a GCF here? Okay, so take out a 4. 12 divided by 4, good. It'll be 3x squared minus 1. Can I factor this further? Are they both perfect squares? No. So that's not a perfect square. This would be as far as that factors. I can take a GCF and that's it. In order for something with two terms to factor further, they have to both be perfect squares and it has to be a minus sign. So perfect squares and a minus. So the next one, 9x squared plus 16. Can I factor that? There's no minus sign. They're both perfect squares, but that plus sign, I can't factor it. There's nothing I can do with that. There's no GCF I can take out. There's nothing. And every year people are like, wait a minute, yeah, you can. They're like, let's do 3x plus 4 and 3x plus 4. Right? They're like, those are perfect squares. I'll just do two plus signs. Is that going to work? No. The middle would give you 12x, and that one would give you another 12x, which would give you 24x, nothing in between. So this, can't do that. Okay, it's got to be a minus so that I can have 1 plus, 1 minus, so I can cancel things. All right, how about that last one? Is that a difference of squares? Yeah. That's perfect square? That's perfect square? Minus sign? I'm good. So how does this factor? And 6x minus 1. All right, and again, if you check them, inside, outside, they better cancel. Okay, if they cancel, then we know we're good. These are my favorite because they should be real fast. They are my favorite. All right, so x squared minus 49. Is that a difference of squares? Yeah. They're both perfect squares, and I have a minus sign. Perfect. X plus 7, x minus 7. And again, if you're trying to reason through this, you'd be like, all right, I'd be like, I have 1 and 1, so x and x. Here, you'd be like, I have 1 and 49, or 7 and 7. And then I'm trying to get, remember, there's technically a 0x in the middle, so I'm trying to get them to cancel out. And if I check this, 7x minus 7x, I get 0x. They canceled out. So it works. 16x squared minus 1. Yeah, those are both perfect squares and a minus sign. 4x plus 1, 4x minus 1. How are they doing that so fast? They're perfect squares. Yeah, you're just doing it square root. Do the next one on your own. I'll give you like 15 seconds. You're already done. It really shouldn't take you more than like 15 seconds, if that. Depends how fast you're ready. What? Christian, what'd you get? Aren't we loving these? Do you see how easy these are? So please tell me tomorrow and next week why people suddenly don't know how to do these, okay? Somebody please tell me. Yeah. Yes. As long as what you have left has a minus in between them? Yep. As long as what you're looking at has both perfect squares and a minus in between, you're fine. Can you do what? A GCF. How about you give me a minute? We'll go through some, and then I'll answer that question. And you're moving ahead of me. All right, guys. How about 50x squared minus 18? Are those both perfect squares? But what's the first thing we look for? A GCF, which is 2. So, guys, the first thing you always look for, no matter what, is a GCF. We want to be able to take those out. So GCF here is 2. 25x squared minus 9. Okay, once you pull out the GCF, look at what you have. Is that now a difference of squares? Yeah, they're both perfect squares, and there's a minus. Yep, don't lose baby brother. He's just hanging around, right? Yes. Yeah, don't lose baby brother. Your mom's going to be mad at you. 5x plus 3, 5x minus 3. Yep, and do not lose baby brother. I'm going to tell you right now, this next problem will be the most missed problem that I would possibly give you. The 64x squared minus 100. It is the most missed problem. Take a minute. Work through it. Take a minute. 64x squared minus 100. Why is this the most missed problem of all of them? Wrong. 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 Most missed problem. Happens all the time. Oh, John thinks he's got it. Wrong. John thought he had it. Wrong. Wrong. Oh, Donnie's on the right path. No, wrong. Do you have a GCF still sitting inside those parentheses? Guys, what's the first thing we look for? GCF. Bigger. 4. Hold on, let's talk. Okay, let me talk through this from a couple different ways. Guys, the first thing, no matter what, is GCF. Okay, so it is 4. So I take out a 4 minus 25. And then is that now something I can take further? Yes. Baby brother follows you down. Good. 4x plus 5, 4x minus 5. Now, that is the answer that will get you full credit. Most of you gave me 8x plus 10 and 8x minus 10 because you're like, yeah, they're both perfect squares. You just kind of went for it. Always take out the GCF first because look, there's a greatest common factor in here. So 2 goes into here. Change that one to 4x plus 5. 2 goes into here. So 4x minus 5. And then I have 2 times 2, which is 4. There's the 4. You're making extra work for yourselves. But yeah, students see that and they're like, oh, perfect squares, and they just jump right into it. Be careful. GCF always first. Okay, what about 12x squared minus 75? GCF of what? 3. There is a 3 for GCF there. Because, yeah, a lot of times students look at that and they're like, that's not perfect squares. I can't do anything. GCF, guys. I'm going to tattoo it all across all your forehead. So you look at each other and that's all you see is GCF. So what? 4x squared. Good. Once you took out the GCF, now do you have perfect squares and a minus sign? Now we do. And don't forget baby brother. Yeah. 6 is not going to 75. It goes into 72, not 75. All right, 121x squared minus 144. Are they perfect squares? Was there a GCF? The numbers are big, right? And you're like, I don't know. All right, if you're not sure, because you're like, numbers are kind of big, but you're like, but they are perfect squares. So how does it factor? So if you were not sure if there was a GCF to begin with, look here. Do you have a GCF left inside? No, which means you did not have one from the beginning, right? When we did this one, those of you who went this route first, GCFs are sitting in here. So you could have pulled them out after the fact, okay? You can, as long as in your mind you're constantly like, is there a GCF hiding in there? Like that should be like always like in your mind, looking for that. Yeah, so then you'd have been like, oh wait, there's a GCF in those. I probably should have taken something out to begin with. Yeah, so this one freaks people out because the numbers are so big. But if I do my factoring, I'm like, there's no GCF, so I was okay. There was nothing from the beginning. How about x squared plus 100? 0? What does this mean? Undefined, no solution, can't do anything with it, unfactorable. I'm just too lazy to write unfactorable. So there's a plus sign. If that was a minus sign, if there was a minus sign, that'd be great. X plus 10, x minus 10. But it's a plus. I can't do it. What about 4x squared minus 75? Undefined as well. I can't do anything here. Unfactorable. Can't do it. Because there's a minus, and the 4 is perfect square, but 75 is not. No GCF to pull something out to hope it is. Like, there's nothing there. Okay, so if you're going to have two terms, it's got to be what two things? Negative and perfect squares. Now, real quick, side note, because I know this kind of thing comes up. What if I give you negative 4x squared plus 49? So sometimes students see this and they're automatically like, can't do it, there's plus sign in between. What's the first thing we look for? GCF's the first thing. And that first term's negative. What did we talk about yesterday? You got to take it out. So you would take out the negative 1, right? That's going to flip everything to 4x squared minus 49. And now I have perfect squares. I could do this. And there's a minus in between. You just can't lose baby brother stuff. Okay? So just be aware of that. Again, that same rule. If that first one's negative, we got to be taking that out. Yes, sir? First term was negative. You got to take it out. Yeah, we talked about that yesterday. It still follows through on all factoring. First one's negative, take it out. Okay.